is in descending order, no problem, but the denominator is not. As you remember, the first step in anything is arrange everything in descending order. And the next question is negative leading coefficient. Yes, of course. So I have to factor out the negative leading coefficient. All these are must steps. Oh, I'm sorry. Let me start from scratch. Sorry. So we had x minus 3 over 3 minus x. The numerator is in descending order, no problem. But the denominator is not. I have to rearrange it. And according to our strategy that we can never ever forget, we can never skip any steps, then we have to factor out the negative leading coefficient. That's a must. So the denominator becomes x minus 3. I cannot simplify before I state the restrictions. No matter what Pearson says, moving forward in your math adventure, please remember you cannot simplify. No matter what anybody tells you, you have to state the restriction. And now you can simplify because you simplify a factor. The numerator is 1, the denominator is 1, but there is a minus in front. The correct answer is this. Again, no matter what they say. Any questions?
No, thank you. I don't know why it was so complicated, but I had to.
That's okay. I was just looking to see if I forgot. No, it's in there. Okay, good.
My next question is 19.
Very good. Let's take a look. Okay, let me know if this is good enough, or you can give us your question. Is this good enough?
Yes, because that looks a little harder than mine. Yes.
Okay, very good. Divided by t minus 5, everything squared. Perfect. Perfect example. The numerator, not what I want to see, ever. The denominator is nice and clean. There is nothing I can do about it. The next step, I don't like the negative leading coefficient. This is the strategy that I studied. First, mandatory descending order. Secondly, greatest common factors including negative leading coefficient. Now I see that the numerator is factorable because it's the sum of the difference of squares. I cannot touch it before I state a restriction, and I know that t can never be 5. I remove a factor of t minus 5 with another factor of t minus 5. The negative sign stays outside. The numerator is now only t plus 5, and the denominator is only t minus 5. If anybody tries to simplify t with t or 5 with 5, would make a terrible mistake. We only simplify factors. We are not allowed to simplify terms. So, no matter what Pearson says, you know moving forward, even if you cannot put it in anywhere, that this is the simplified form of that expression under the condition that t is negative 5. This expression will not simplify to this if t is 5. Excellent. Is this clear?
Yeah, yes. Like mine was 1 minus r2 and then parentheses r minus 1 squared, but yes, thank you.
Very good. Any questions here? Anybody? Any questions here?
My next one is 23.
Let's take a look at 23. Very good. See if this is good enough, or you can give us yours.
Yeah, that's good.
Okay, very good. We had a similar, I tried to cover all my bases, and I think we had a similar problem. Plus 6 times x minus 6 over x squared minus 1. Very good. I start from the very first polynomial, and I see that it has x in common. I have to pull out the greatest common factor. The denominator factors into x minus 1 and x minus 6. How come? The product is 6 and the sum is negative 7. Times x minus 6. And I know that the denominator factors because it's a difference of squares. The difference of squares is the easiest formula or special product that we can work with. I have 1, 2, 3 restrictions to write. I don't touch anything before I write that x cannot be 1, x cannot be negative 1, and x cannot be 6. If I state restrictions after I simplify, it's too late. I have to state restrictions and then I'm allowed to simplify. So let's simplify. A factor of x minus 6 with a factor of x minus 6. A factor of x plus 1 with a factor of x plus 1. Only one from the top and one from the bottom. Not both from the top or both from the bottom. That's not possible. So only x plus 1 and only x minus 6. You cannot simplify x minus 1 times x minus 1. Because one student asked me last week, how come you don't simplify these two? How can I? They're in the denominator. They're multiplied. So x times 1 is x. X minus 1 times 1 times x minus 1 times 1 is x minus 1 squared. The correct answer is this. So the simplified form is x over x minus 1 squared, assuming that x does not ever equal plus or minus 1 or 6.
You make it look so easy.
Good, I'm
question
glad.
34?
Is this clear? All steps?
Yeah.
Perfect.
Like I said, you make it look easy.
Anybody? Yeah, Rachel, just 1 second. Anybody else has questions on these? Yes. Please continue.
34?
Let's take a look at 34. See if this is good enough.
Yeah.
Okay, so determine the polynomial in the second denominator such that the following statement is true. Okay, we did not have an example like this. Thank you so much for bringing this to class. So 2x squared plus 9x minus 5, and that is divided by 2x squared minus 9x plus 10 over whatever, and this has to simplify to x plus 2 over 2x minus 1. Very good example. Thank you, thank you. Perfect. So the first thing I need to do is factor this completely, factor this completely, factor this completely, and flip. Why flip? Because when I divide two fractions, I keep the first fraction unchanged, and I multiply by the multiplicative inverse of the second fraction. So, before I write anything, let's take this aside, because this is the long procedure. The same thing here. So, let's try. Descending order, no greatest common factor, no special product. 1 is not the leading coefficient, so I'm down to the last chance. Now, can anyone give us the product and the sum? And then we'll figure out how to factor.
Negative 10 and 9?
Yes, the product is indeed negative 10 because we have to incorporate this. It's a must. And the sum never changes. So we need to find two numbers because the product is negative. We want a positive and a negative. And the negative has to be small. The positive has to be large because the sum is 9. And both have to be fulfilled.
10 times negative 1?
10 times negative 1. 10 minus 1 is 9, correct. 10 times negative 1, negative 10, correct. But now, I'm jumping over here. I have to change the middle term using these numbers. So, 2x squared plus 10x minus x and minus 5. I notice again that we did not change the problem. The problem is still 9x. But we are in the position now to use factoring by grouping because I had 4 terms. Here I could not use factoring by grouping because I had 3 terms. This procedure allowed me to represent 9x in the form of 2 terms, so I can factor by grouping. So what do we factor out from the first 2 terms?
2x.
Indeed. What is left in parentheses?
X minus 5.
Okay.
X plus 5.
X plus 5. If I do not get an x plus 5 from the other 2, I made a mistake. How come? I know that this is a factor because I already found the 2 numbers that work. So this must be a factor coming out from the other 2. I refuse to look before I write it because I may come up with something and I get stuck by mistake. But once I wrote it, I know it's there. So we need a sign and a factor.
-1.
-1. Although we don't write -1, we do write the negative, but we don't write the 1. I put it there just in case. So then the final simplified form, factor form is I pull out the common factor first. It's not a mistake to put 2x minus 1 first, but I take the common factor out first and then I'm left with 2x minus 1. So this is a simplified form. This is an easy difference of squares. Now I have the factor form for this. I want to work on that and then put it all together. So this time we have 2x squared minus 9x and plus 10. The same procedure, it goes through my mind quickly. Trinomial, descending order, greatest common factor, no. Negative leading coefficient, no. Special product, no. 1 is a leading coefficient, no. I'm down to the last chance, the long procedure. So I need 2 numbers whose product is and whose sum is.
-5, -4.
So we have 20. So the product is positive, so they either both are positive or both negative. But because the sum is -9, both have to be negative. Negative, negative. -4 and -5. Their sum is -9, yes. Their product is 20, yes. So now I continue. I'm going to jump over all this. And I rewrite this using these. That was the whole purpose of finding -4 and -5. So -4x, -5x, and plus 10. I did not change the problem. I changed its outlook. I changed it from 3 terms to 4 terms specifically so I can factor by grouping. I refuse to look before I determine what I need. So what do we 2x indeed, in parentheses.
X minus 2.
Indeed. I do not look. I write it first so that I save time and I don't have to wander and I don't have to waste any more time. I absolutely need a sign and the factor.
-5.
-5 indeed. Because -5 times this is this and -5 times this is this. I pull out the common factor first, but that's me. The order is not important. And then I write 2x minus 5. So, finally I go back to the problem. The numerator now is x plus 2. This is the easiest of the special products. It's a binomial difference of squares. This I have the factor form, which is right here. So x plus 5 and 2x minus 1. I'm going to already flip this. Change it into a product, question mark. I don't have that yet, but I have the factor form, which is right here. Assuming everything is within the allowed factors. Let's say for now, just for this exercise, we will not state restrictions. We assume that all restrictions are taken care of. Okay, good. Now they say that this equals, let me copy it and put it aside, and I don't have it anymore. So they said that the answer is x plus 2 over 2x minus 1. Okay. So let's take a look. What do we need in the numerator to make this happen? So first of all, x minus 2 will go away with an x minus 2. Now, x plus 2 has to stay. Why has to stay? Because it's here in the final answer. 2x minus 1 has to stay. Why? Because it has to be in the final answer. Now, I already know what should the question mark be. Can anyone tell us what should the question mark be?
X plus 5, 2x minus 5.
Because it has to go away with this, and it has to go away with this. And that is the final answer. Now, carefully read the, let's read the fine print. Do they want it factored? Do they want it expanded? How do they want it? The polynomial in the second denominator is. So, they do not want the factored form. So what I need to do is use FOIL on x plus 5, 2x minus 5, distribute. So 2x squared minus 5x plus 10x, 5x minus 25. This is what they want us to enter, not this. Although they are correct. If you enter this, they should not say it's wrong. But they want a polynomial. They don't want the factored form of this polynomial. So careful and enter the polynomial. Because it says the polynomial.
Thank you so much. I tried that one probably 10 different times.
Is it clear now?
Yes,
I have to say that this is a problem way too long for a test. So you're not going to see this. I'm not, you know me, I like to test the basics. So this is not going to be a problem on the test or the final exam because it's too long. But it's all based on what we studied. Good. Next question. It's a very good practice.
I'm actually done with 7.1. I need to go to 7.2 and I have a couple. Unless someone else has questions.
Anybody else has questions from 7.1? Okay, let's look at 7.2. From practice, right?
Yep.
Let's see what I get.
Question 28 and 37.